I'm Sergio from Snapd team. Work for of Canonical. I'm the QA responsible for the snaps. My idea is to present about what's a spread and also to give you our experience using it, and also we use that in our projects like Snarcraft and core systems. So first, quick introduction about testing stuff. What we want to do with testing is basically to compare the expected results that we have for the system, for software, with the actual results. And when we do that, we want to catch ASAP any problem we could have. And when? Well, when any developer makes a commit, a new PR, ASAP as possible to make able to fix it as soon as possible. It's much cheaper than if we catch it later. So our problem in the project initially was that we had an old framework. They used to take a lot to run tests. It was not easy to parallelize executions. It was very difficult to understand the results because there were spread in many files. So time ago, spread came to fix these problems. We wanted something to run fast, be able to parallelize as much as possible the executions, reliable results, easy to write tests. So because before we used to write the test in very complex model, and we needed also something to compile all the results in the same file, so it's easy to re-understand the full execution of this. Because many times when you run in parallel, you have the problem that then you have a lot of different logs. So wanted to unify that in a very unique result file. And also something that allows us to reproduce errors and debug errors in the environment where we are testing that. This was the most important thing, and always to cover many operating systems. And at that point when we created the spread, we just tested Ubuntu, but at the end we started testing in other distributions as well, and Ubuntu Core, in many systems. Take a look at that. So we created a spread. We started using time ago. Spread provides us a very easy way to parallelize executions, so you can run in containers, run in cloud providers, running QEMU machines, everything in parallel, and you can even parallelize inside. You could run many tests in parallel using LXD. So this is a very quick way. We have a very quick way to run, and we reduce a lot the time that we take to run the full test suite. For example, in Snapd, we run like 11,000 tests in 1 hour. And I'm speaking about integration tests. So each test interact Snapd with the operating system, with the stores, with a lot of other systems. It can be used also for unit testing, but the main purpose of this is to run system tests, integrated tests with our components. It supports many distributions. We test Fedora, CentOS, OpenSUSE, Debian, so it runs everywhere. And something important that we discovered that it's not specific to testing. You can use it for any other task, such as we maintain systems with this. It's very easy to connect to other machines, run what you want, and get the results from there. So we use it for many other things. And that's a very good point, is that it's very easy to integrate in CI systems. So we are using GitHub Actions, but it can be used in Travis, Jenkins, everywhere. It's very easy. It's command line. The results are very easy to read in the log, and it's not consuming too much memory. So it can be integrated everywhere. So I try to resume how it works, but basically, spread what it does is to allocate machines, execute things in the machines, and then deallocate that. It could be executed in cloud providers or in containers. This is the best picture I could find. But also in devices. So we used to test in Raspberry Pis and Dragon Balls, well, everywhere. And that's useful for Ubuntu Core as well and for any other situation. So if you, for example, you are building a snap and you want to test the snap in Ubuntu Core in a specific device, it's very easy to use a spread for that. Okay, we're going to see how we run spread, what we run and where we can run it. To go fast because I have a demo. And so first we are telling you how we run spread. We have a pretty simple command line, few commands. It's very simple. And we have a single configuration file for the project. So it's very easy to configure a project, to start with spread. And it's very easy to run a command line. It's very, very simple thing, and execute what you want to run. And it's very powerful, that syntax. You will see some examples now. But there are some very interesting features, like you can specify the timeouts for the execution. So you have, if you have a problem that some test is getting stuck, well, it will automatically kill at some point, or it could give you some messages at some point, some warnings to after a few minutes. Also, it's very easy to configure the number of workers you want to use. For example, if you want to run in 10 parallel machines in QEMU or 10 LXD containers, you can do it just with the number in the configuration. It's very, very simple for that. And in the cloud, that's the same. You can specify the image you want to use, the number of workers, and it will spread the executions and manage the executions in the workers. Well, let's see some examples. These are, I try to make simple things. You just use a spread, where you want to run, which system are you going to use, and the test. This is the test we have in snapd. But then you can run, if you want, spread where you want to run the system, but also a test suite, it will run the whole test suite. This is an example with this command. What the bug is if you run a test that could fail, the debug flag will stop the execution and give you a shell there so you can debug the real problem. It happens the same if you were depending in the system will show always the same behavior. So you could have a debug shell in a Google machine, but also in a container anywhere, devices, the same. And also you can mix things. You can run this test suite in LXD, but also this test in Google. But also if you want, if you remove the system, you will run all the systems that you have configured for LXD. So you could run just LXD, and the test main, it will run in all LXD you have configured all the tests in the main suite. It's a very simple way. It's very powerful because you can make a lot of configurations for that, a lot of combinations. The good part of this is that in a single line you run and you get all the results. And so when you integrate that with CI, you get just one file and all the results you want for your validation. That's pretty powerful because we're using that and it's working very, very well. This is a configuration file that we use. It's a very simple one, but basically this is the way you configure a backend. You just configure, this is a QEMU example. You have some environment variables that you share in the whole project. That's very useful as well. They have the debug section. So this debug each means that if any test in your project fails, the message will be executed and you will get that information in the log. So it's a very useful thing as well. Then you have a kill timeout. So if a test takes more than 10 minutes, killed, and the next continue. And then we have the prepare and restore section where you can find how to prepare and restore a project, but the same can be done for a test suite. So you have the test suite that's called main. You can define how to prepare it and restore it. For example, in snapd, what we do is we build the snapd when we prepare the project, and then we install it when we prepare the suite, and we remove it when we finish the suite. And we do the same for all the suites we have. So if you want to test a snap, what you do, for example, is when we prepare the project, you just build Snapcraft, you install Snapcraft, you build the snap, and then you test it in all the suites you want to have. And then you have configuration per test suite. You can define also environment variables for the test suite. You could define which system should run that test suite, which backends, everything. So it's very powerful, and this is a complex but simple representation of how you organize the project. But basically, what you do is you have a directory for the project, and then you have directories for your test suite, and for each test suite you have directories for each test and a test file definition for each. We'll see an example then, because seems to be complex, but it's very simple organization of the test you can have. But that's how we organize that. You could have as many test suites you want. So this is a bit how spread works. This is a very all the test tools do the same. Basically, you just prepare the system, you execute the test, and then you clean up. That's basically, so you can iterate over this, and you run the full test suite. So what Spread is doing first is preparing the project, then we'll prepare the test suite, and then execute. That could happen in different order if we define that we want to run in more than one worker. So if you want to run into parallel, it will prepare, executing. It's a random order, what it's following. And something important is that is cascading. So if you define, for example, an environment variable here, it will be used in all the project. If you define variables here, it will be used in all the tests for that test suite. And well, so it's very easy to reuse environment variables and reuse code that you can organize in the prepare and restore. And the same for the debug. Yeah, things easy. And yeah, well, you could well, same ADN but different flows. That's the idea of data-driven testing. So the idea is you can define different environment variables to reuse the same test, but have a different behavior. So it's very easy. So you have some tests that are very repetitive. You can just use that approach that in Spread is called variant to reuse the same test. Yeah, it's very powerful that as well. And something important is that for each set of inputs you define, it will run, it will create a runner, and it will execute as a different test. So if you have 5 different inputs, it will run 5 tests in all the systems supported and all the backend supported for that execution. So this is how you define a test. Something important, the tests are running bash scripts. Most of the things we do is in bash. We can test it in bash. But as is this in this example, you can import everything. So if you want to run Python code, if you want to run any other programming language, you can just do it. You can import things. You can define whatever you want to run, and you can even run to test graphical things. So it's very easy how you do it. Just a YAML file with the environments variables you want to use. This is the way we change how we use the variants, the data-driven testing. And then you prepare, you have a debug, you could have or not a restore section, and the execution part. So what's going to do spread is to run the compose, the prepare. This prepare we have here with the prepare of the test suite and the project. Execute that, then we'll execute that part, the execution part, and then we'll restore. In case of there is a failure at any point, it will execute the debug section, and it will show you the results. And something important is that for each test, you also can define which systems are supported for the test. So if you have, for example, something that's just for Ubuntu, you can say here Ubuntu, but also you can say in which systems you are not supported. For example, in this case, some example, it will execute in all the systems, but those ones. What else? Then we have backends. These are the supported ones. The backends is a part of a spread that knows how to allocate and deallocate the machines. So when you say, I want to run something in snapd, what's going to do spread is going to the snapd backends, internal part of snapd, and will create a machine, allocate the machine for you, and then when you finish, you will destroy it. So you don't care about how to create machines and destroy it. It will be, it's included in the snapd, and the same for different systems. Also, we're working. We have already done for Amazon and some draft backend for OpenStack. If you can run it in a cloud environment, it's amazing because it's really fast and it's very easy to parallelize and execute and cover all the systems you want to cover. It's very easy. And also we have an ad hoc backend which allow you to define your own way to allocate or deallocate the system. We use it a lot for devices. So when you have a device someplace that you want to test, so you don't need to allocate or deallocate that, it already exists. So what you do is just to connect to SSH and run the test in a specific device. We use that a lot for Raspberry Pis and all the external devices we support for Ubuntu Core. Yeah, this is an example about LXD, which systems could we support. We'll see an example about this. Well, this is just wanted to show you how to configure a system for a backend. You just find which systems are supported. Some backends need to configure user and password, but for others not needed. And the same, for example, for Google, mostly for cloud environments, you need to define which image you want to use. And you have some extra things, but here you have a configuration that's the workers. It means that it will create always, it will run in this case in 8 machines in parallel. This is very useful to speed up executions. I have time for demos. Okay. Let me try to make that work. Okay. So this is a project. I will run I already spread. Yeah. This is an execution that will run. So here what shows a bit how it's configured. This is a project that we use for some tools. There is a test that's called OS query that we use to check different properties of the system. Will show. And there is a task file there. It's a test. That's the organization we have. Now it's going to run the test in Google system, in Google backend, but also in QEMU. So we just run that and allocated all the machines. Now it's connecting. So first allocate, then try to connect through SSH to the machines. But also starting the QEMU VMs. I rename a file so just to make that fail, so you can see the results. But it's in purpose, and the same I did for one test that I just exit one, so it should fail. And now it's executing. You will see how all the lines. So you see some preparing, execution, and restoration, and we'll see the full execution in the same log, and everything is together. This is a very simple example, but happens it's very fast. Now it was running in the cloud, so you have all the connection, terminal, the setup for the machines. It's very good. This test failed, so you see what will happen before it failed. It could include more debug information in there. So the result is one aborted task is the task that could not be executed because, well, it failed to trigger the QEMU. And one test that failed, here you have so it's very simple now that you will see, and there you have all the information about the execution. There is something that perhaps it's useful. Debug. So it's a very simple. What I did is just to run a set of tests in LXD. Here I have 3 machines in LXD in my environment. So the idea is one is going to fail, the other ones are going to pass. It's starting the LXD containers. It will run, and at some point I get this it failed. So I have now inside the container I am just querying a bit to see what happened as an example, but you can do everything you want. Then you exit, it continues. In case you want to debug more than one, it's the same. It will stop in all the errors it finds. You will see. You will have all the debug sessions for this. And the same for shell. You can use dash shell instead of debug, and you will have a shell session for the test you want. So this is try to make simple, and yeah. Let me see if I can. Okay. So don't be that guy. Just to try to automate as much as possible and integrate everything with CI, and yeah, the life will be much simpler. Okay. And well, if you have any question, no more time. But if you want to use a spread or to start using that in the project, just ping me. I will be here today or tomorrow. And well, if you're from Canonical, you can ping me at the most first. Okay, that's it. Thank you.